Hi, I'm Demi, and our position paper answers the question, do we need a million satellites in orbit? The satellite industry is currently booming. There are a lot of excitement in the field, and we're currently at tens of mission-specific constellations. These satellite constellations have many different applications, including communication, Earth monitoring, meteorology, Earth observations, and a lot more. Currently, Starlink has deployed over 6,000 satellites. OneWeb has over 600, Planet Labs has over 200 deployed already, and many of these companies have many more satellites planned for deployment. So we're currently at thousands of satellites deployed already, and we're heading towards the million range, with over 1 million satellites planned and filed for deployment already. However, do we want a million satellites in orbit? Well, first of all, rocket launches are bad for the environment, and sending 1 million satellites in orbit requires tens of thousands of rocket launches. Specifically, the black carbon produced from rocket launches are 500 times more efficient at warming than all other sources of black carbon because they inject black carbon directly into the upper atmosphere. The environmental impacts are making to headlines. They're a major concern for the space race. Furthermore, this will also increase chances of injury and damage due to re-entry. According to the FAA, with all the projected satellites deployment, every 2 years, one person is expected to be injured or even killed by re-entry. In fact, similar thing is happening already. Satellite also hinder astronomy. Multiple papers have reported and discussed how both ground and space-based astronomical observation images became unusable because the exposure is affected by these low Earth orbit satellites. To solve these problems, we want to answer the question, can we have a small number of general purpose constellation perform the functions of tens of mission-specific constellations? Here is our proposal, Constellation as a Service platform. It will provide space mission as a utility, just like cloud computing and power. Each satellites within such platform are equipped with a wide range of capabilities. So GPU and FPGA for computing, RGB sensor and radar for sensing, radio and optical technology for communication. Customer can lease virtual satellites, just like leasing virtual machine from a server, and each virtual satellite is fulfilled through the capabilities of one or more physical satellites. So our proposal generalizes the current subscription model. While the current satellite platforms can be shared by multiple users, customer either gets data or services without access to hardware. So for example, you can lease part of networks from Starlink, or customers can run their code exclusively on one set of hardware. For example, you can lease physical satellites from Satellogic. So our model offers a notion of global constellation by giving an abstraction of virtual satellites. It can satisfy both global and regional coverage demand. Users have full control over these virtual satellites, including which software to run, which data to collect, how to communicate, how the virtual satellites are configured. So overall, a more general model. So in the image on the left, you can see how user can request for virtual global constellation, and user can also request for regional coverage, shown in the image on the right. But is this idea feasible? Do we have the technology to support CAS? The answer is yes, and one evidence is CubeSats. They're tiny satellites made from commercial off-the-shelf hardware and software. Developers can put different equipment onto a CubeSat based on their need. Here are some places where you can shop for satellites part, and these modular satellites are very easy to work with. The components can be put together easily as they communicate through standard interfaces like Ethernets or USBs. I actually have the experience of building a satellite, building a CubeSat back in high school. So a group of us high school students were able to build a CubeSat from ground up. Well, therefore, satellite capability should not be a barrier. Well, given this, can we deploy CAS right now? The answer is no, and there are two main categories of challenges. One, we want to ensure our solution is financially viable. And two, we want to ensure that our solution does not compromise on security guarantees provided by mission-specific constellations. So the first challenge is to ensure efficiency. And CaaS platforms have similar challenges to other shared platforms like cloud, edge computing, Internet of Things, ride-share platforms. Now, what make CaaS platforms unique are satellites have very limited power on board, but they also have predictable power harvesting cycle through solar panels. So there's room to leverage the mission-specific patterns and requirements to minimize power consumptions, make use of the power harvesting cycle, and minimizing the interference from mission-agnostic operations to the missions themselves. Satellites are also mobile and follow their own orbits around the globe, but mission can be region-specific. So mission logic will need to move between satellites. Although this type of scheduling problems are very well studied in different scenarios, these scenarios will still require more consideration because the resources are limited and scarce and have very high cost. Meanwhile, they also have unique and predictable pattern in this type of platform. The second challenge is security and privacy. So this new platform comes with new attack surfaces. With satellite sharing and the nature of space mission, a constellation as a service platform should have no tolerance for security vulnerabilities. Here are some potential ways malicious user can exploit the platform. So on one single satellite, as multiple users share this one set of unique hardware, a malicious user can infer other users' mission parameters by observing the satellite's configurations. For example, a satellite at one physical location can observe different areas on Earth by changing its attitude. So a malicious user can infer what regions other users are looking at by tracking the attitude. Now, at the constellation level, a malicious user can infer the region of interest based on global resource availability. A single malicious user can deploy many small tasks onto multiple satellites to infer the hot regions on the planet. So overall, the CaaS platforms will require innovations in both satellites operating system and constellation level scheduler to ensure security and privacy. Note that our consideration for security is not exhaustive. We highlight a few problems that are worth more investigation, and given the low tolerance for vulnerabilities, security should be of high priority. To contextualize different challenges of this platform, we present the strawman architecture. So first we'll have the scheduler that takes in user requests and generates a schedule while meeting policy constraints, user priorities, resource availabilities, and cost models. Then it configures satellites and ground station based on the schedule. On the satellites, we need a new hypervisor to abstract satellites hardware. So this architecture leads to two high-level questions. First, can we make the scheduler fair, efficient, and secure? For this, we built a simulator to help explore scheduling algorithms. The second question, can we design a lightweight and secure operating system for a shared satellite platform? And we're currently working on making a lightweight and secure operating system for satellite sharing. Let's have a quick look at the simulator. The simulator takes in physical constellation and configurations as well as user demand. Here's a quick example of how satellite capacity is specified in the simulator. Next, the simulator validates the TLEs, construct a constellation, and pass it into an optimization engine. In our case, we're using Google OR tools to solve the scheduling problems based on optimization rules and goals. If the setup is satisfiable, it visualizes the output. Here is a sample output. It has two users, red and teal. And the big spheres represent the virtual constellations user demanded, and each physical constellation has color labels to indicate assignments. With this, I concluded my presentation. I hope I've convinced you on another path other than having a million satellites in space, and a constellation as a service platform is a worthy solution to consider. Thank you for listening.